Okay, so I asked you to work on this little sheet after your test, for homework after your test. The front side hopefully was fairly decent. The first one might have caused you some difficulties if you didn't quite understand what I was doing in a video from the day before. So it says, which pair of concurrent forces may produce a resultant of 20 newtons? Remember, concurrent forces are two or more forces that are acting on the same object at the same time. So what it's saying then is, this pair, can it in any possible way produce a resultant of 20 newtons? So if you think back to the other day, we said that there are different ways to add forces together. If they're acting in the same direction, you'll get the maximum force they can produce. If they're acting in totally opposite directions, you'll get the minimum force they can produce. And if the 20 newtons falls between the minimum and the maximum, then these two forces can produce that. So getting the minimum force when they're acting in opposite directions, you subtract. And so for A, the minimum force that it can give you is 5 newtons, right? 10 minus 5. And the maximum is 15 newtons. And 20 does not fall in there. So A is not a possibility. Let's do C just because it's underneath here. 50 and 20, the minimum, subtract them, 30 newtons. The maximum, add them, 80 newtons. 20 does not fall between 30 and 80. Over here, I'm trying to figure out where the edge of my sheet is. The minimum, subtract them, is 0 newtons. The maximum, add them, 40 newtons. 20 does fall in there. And here, 30 and 5, the minimum, 25 newtons. The maximum, 35 newtons. 20 does not fall in there. The only set that can produce a resultant of 20 newtons is the 20 and 20. All right, number 2. A resultant of 7 newtons, the resultant of a 7 Newton force and a 12 Newton force is 5 newtons. What must be the angle between them? Well, if you subtract 12 and 7, you get 5. So the angle between them must be 180 degrees. Again, going back to the way we had forces. The resultant magnitude of two 30 Newton forces is 60 newtons. What must be the angle between the original forces? They must be acting in the same direction, which would be 0 degrees. So these guys must have been acting opposite each other, but in number 3, the two 30s must be going in the same direction so that they add up to give you 60, and that would be a 0 degree angle between them, right? Whereas up here, one would be going one way and the other, and that's 180 degrees between them. All right. Ooh, how did that answer get there? One moment while I erase this. All right. So in this one, I didn't do a very good job erasing it. So in this one it says, which vector, there we go, which vector best represents the resultant of F1 and F2 acting on point P? Okay, so here's point P, and we have two forces acting on it, and we want to know the resultant. Well, right now we can't add these two together. They are not head to tail. So leave F1 where it is, and take F2 and slide it over so that it stays parallel to its original location. And so then the resultant would go like this. And which one is that? It would be choice C. I see I also did it down here. I used to use this sheet before. Okay, so number 5 says, which force would act concurrently with K to produce L? So this time we want the resultant to be L. So we're going to slide L over so that it starts where K starts. And so then what force do we need to add to K so that the resultant is L? It's a force going like this, which would be choice B. Okay, so that was it for the front. Hopefully not too bad. The back might be another story. So on the back, determine the resultant or net force exerted on a stationary elephant by two clowns pulling on a rope at right angles to each other with forces of 400 and 300 newtons respectively. Okay, so my elephant is going to be a box. And so one dude is pulling with a force of 400 newtons, and it doesn't say which way. And the other dude is pulling with a force of 300 newtons, and it doesn't say which way. All it says is that they're at right angles with each other. Okay, so before we can add these together, we need to slide one so that it's on the head of the other. So I'm going to take my 300 Newton force and I'm going to slide it over here. And so now they're head to tail. So now my resultant will be here. Okay, and I can find it. It's a 3, 4, 5 triangle. So 3 squared plus 4 squared will be 5 squared with 2 zeros. And then I also need to measure the angle. And so I would get the angle, not measure it, but find it. I would get the angle by doing tan theta is equal to 300 newtons over 400 newtons. So inverse tan of 0.75, theta is equal to 36.87 degrees. Okay, and it would be 36.87 degrees from the 400 Newton force. We can't really say east and north because we weren't told which directions. So we could just write something like at an angle of 36.87 degrees WRT 400 with respect to the 400 Newton one. WRT with respect to. Number 2. 3 ropes pulled down on a weight scale that is suspended from the ceiling. 1 rope pulled straight down with a force of 200 newtons. The force of each of the other 2 is 200 newtons as well. And they act on either side of the central one at an angle of 30 degrees. What is the weight on the scale? Okay, so a scale is like the scale that I have hanging in the ceiling of my classroom. And it has a string hanging down. So a string that's coming straight down, it has an F1 of 200 newtons. But now it says and so the scale's going to read, right, how much force it's experiencing. So if it was just that force, the scale would read 200 newtons. But now you're going to attach 2 other strings, one this way and one this way. So F2 and F3. And it says both of these as well are 200 newtons. I'm just going to write it up here. Okay? And it tells us that this angle in here is 30 degrees for both of them. And the question wants to know then, what's the scale going to read? Well, these 2 out at an angle, they have those components that we were talking about, right? And so you're going to need to find their components. I'm just looking for another color because I realized that the purple didn't show up that well. It was hard to tell it wasn't blue. Let's try green. So these 2, so this F2 has a component in the Y direction and a component in the X direction. So this is going to be F2X and this is going to be F2Y. Okay? And then number 3 also has a component in the Y direction and a component in the X direction, F3X and F3Y. Now what's going to happen with F2X and F3X? Because the angles are equal and the forces are equal and they're pulling in opposite directions, the X components should just cancel each other out. And what the scale is going to read are the 3 downward components added together. So what we need to do is find those. Now we can prove the x's cancel each other out. F2x and F3x, they're the opposite sides, so they would be sine. So to be sine of 30 degrees is equal to F3x over 200 newtons. So F3x would equal 200 newtons sine of 30. So F3x would equal 100 newtons going one way. And if we did exactly the same thing for number 2, we would get because it's exactly the same numbers, right? Sine